Okay, welcome to another Ginger Mathematician video, and we're going to go through the paper 6 here for the iGCSE 0607. Get a lot of requests for this kind of paper because it is slightly different to the other two papers, so I'm going to go through this nice and carefully, starting with the investigation and then on to the modelling afterwards. This is 1 hour and 40 minutes long. If you like the content, then do subscribe. Alright, let's get started. So we're going to work with Girard's sums here. So Albert Girard, I'm obviously destroying the pronunciation here, a 17th century mathematician, investigated these numbers, which are essentially sums of square numbers. And classic thing that you often have to do on an investigation paper is fill in the gaps, so complete the table. So it's just about understanding exactly what the table means here. So if we take the first column here, so we've got our numbers, and then to work out the second column, we just square the numbers on the left-hand side. So they've given us some examples here, which is really nice. So 2 squared is equal to 4. 20 squared is equal to 400. And this is where the calculator comes in. Some of these we can work out quite easily. So 4 squared is equal to 16. Likewise, working backwards, so what squared gives you 144? Well, that's going to be equal to 12. But for these bigger numbers, I'm going to go to my calculator. It is a calculator paper, and work it out. So I've got my calculator here, so we need to work out the following. So 18 squared, so press enter and get the answer, 324, and 28 squared as well. So let's work those out, 784. So 324 and 784. So let's pop that in. So 324, 784. And here with B, it's exactly the same process. So notice 6 squared gives you 36 going this way. So 10 squared gives you 100. Now working backwards, you want to find the square root. So 64 square rooted is 8. You can use your calculator for this as well to help you. And 196 square rooted is 14. Again, you can use your calculator to work backwards. And now to work out the next column here, well, we just have to add together our square numbers. So in this case, let me use a different color to show you exactly what's going on here. So we've got 36 here, we have 4 there, giving us 40. 36 plus 4 is 40. So notice all we have to do is add on these green numbers that I'm just popping in here. So 324 plus 100 is going to be equal to 424. Some of these are easier to work out than others. So 64 plus 16, that's equal to 80. I'm just looking for the ones that are easier to work out. At this point, I'm going to go over to my GDC and work a few of these things out. Okay, so first of all, we need to add together 784 and 256. So let's just pop that in. 784 plus 256, so that's 1040. So let's pop that in. 1040. And we've got a few others here as well, so 144 plus 196. So 144 plus 196, that's 340. So this is typical for this kind of paper, you're sort of going in between a calculator and different pages of the test as well. Now as we get to the bottom here, it gets a bit more interesting because we have to work out, okay, what's missing. Well, we can work backwards here because if you've got 884 and we have 400, if I take them away from each other, then that will give me this number here. So essentially I'm working out here b squared is equal to n squared minus a squared. So just a quick rearrangement. So if I do 884 minus 400, I get 484. Likewise, I can do it here. So 900 minus 0 is equal to 900. And then I can use the square root button to work out the 2 square roots. So we have the square root of 484. Now things are going right, you'll get whole numbers here. Notice all these numbers so far are whole numbers. Likewise, you can do the square root of 900 giving you 30. So let's pop in those 2 numbers. So we have 22 here and 30 here. And we've got almost all the gaps apart from this one over here, which we haven't talked about so far. And this is where we need to work out what the number is remainder what. So notice remainders are all 0, and all the instruction wants us to do here is take the n number, so this column here, and then divide it by 4. So we're just going to do 1040 divided by 4. 1040, like so, divided by 4. That gives me 260. So I just pop into here, and it's going to be very important, this remainder, when we go into the investigation, exactly what we need. Now you can check my answers here. So if we go to the answers, you can check in all the different numbers. These are numbers in white where you actually get the marks. Right, so now let's use this table. So when a is equal to 2 and b is equal to 4, then n is equal to 4 times some number k. So we need to find out what k is. Now remember, n, we were told this is equal to a squared plus b squared, what I've underlined. So what we need to do is work out what n is equal to a squared plus b squared. Communication is very important on this paper, so show the examiner exactly what you're doing. So we're going to do 2 squared plus 4 squared. So that's going to be equal to 4 plus 16. Again, you can use your calculator for some of this, is equal to 20. And what does the actual mark scheme want us to do here? Well, it wants us to write it as 4 times something. So if we go to our answer here, 20 is the same as 4 times 5. And it wants us to work out the number that's not 4. So I'll highlight it. So it wants us to work out this one here. Therefore, our answer for k is going to, not with the highlighter, that's never a good idea. So there we are, k is equal to 5. Perfect. And on to part 2. So the values of a and b in the table are all even numbers. Yep, that's true. When a is equal to 2m and b is equal to 2n, and n, this capital N, is equal to 4k, find an expression for k in terms of m and n. So we're going to start this in the same way we did the previous question. Notice this paper, it likes to lead on from previous questions. Now in this case, we now know what a is. It's equal to 2m. So wherever I see an a, I'm going to put a 2m. So 2m all squared plus wherever I see a b, I'm going to put 2n all squared. Now, very important where I put the brackets here, because we're squaring the whole thing, we're not just squaring the m. So 2m times 2m, this is the bit to watch out for, is 4m squared. 2 squared is 4, m squared is just m squared. Likewise here, so 2 squared is 4, n squared. So we get 4n squared. And what we're going to do at this point is I'm going to factorize into a single bracket. So notice I want to write it as 4 times something, and the way I can do this is by putting into that single bracket. So what do they have in common? Well, they have a 4 in common, and let's think what's left. So what do we multiply 4 by to get 4m squared? Well, just m squared. What do we multiply 4 by to get 4n squared? Well, just n squared. And notice we've now written it in the way that they want. So if I highlight now the k here, the k here must be equal to that part there. Let me see if I can use a better color than black. That's not very nice. So this 4k needs to equal whatever's inside the bracket here. So our final expression using what we've just done is that k, you'd think I'd learn about the highlighter, wouldn't you? K is equal to m squared plus n squared, like so. So it's just a brief algebraic demonstration of, okay, making k equal m and n from here. Okay, and on to question C. So not all multiples of 4 can be written as the sum of 2 square numbers. Show that there are no values of a and b that give k equals 11. And the key thing here is to write all the combinations that we need. So a and b are all even, so we're only going to be working with even numbers here. So let's work first of all with 2 squared plus 2 squared. So both being 2, that gives me 8. So that's not going to work. And we're looking for combinations that give us that. So you'll see we need to work through an exhaustive list to make sure that we can't actually get 11. So for example, we can try, say, 3 squared plus 1 squared, and we'll get very, very close. That's equal to 10. That doesn't work as well. We can try 3 squared plus 2 squared. Okay, that's going to give us 13. Again, that doesn't work. And as long as you're systematic here on working through the possibilities, notice this combination goes beyond 11. So there are not many other combinations to consider. We could try 2 squared plus 1 squared. That's equal to 5. That also doesn't work as well. So as long as you're systematic and show, okay, well 13, we can't go anything beyond. Say I did 3 squared plus 3 squared. Well, that's always going to be bigger than 13. In this case, it's going to be 18. That also doesn't work. So I've tried all the combinations here of square numbers to try and give myself k as 11. And I've shown very clearly to the examiner I've tried these ideas and then not got to the answer. Okay, you can look through the mark scheme so you can see where you pick up the marks. What I would say with these kind of papers, make sure you're really picking up those marks on that table. So notice there's a whopping 5 marks to actually get on that table. Make sure you're getting every single mark there. The rest of the mark scheme is here as well. I've done the top method here, just going through all the different possibilities to try and give myself 11, and as you can see there, it wasn't possible. Okay, on to question 2. Again, another table question that we want to be getting all 4 marks on. So notice this works in a very similar way to what we did before. We have a complete example at the top here saying exactly what's going on. So it's going to work in the same way here. Again, we're going to use our calculator to work out 21 squared and 19 squared. So we're going to type in 21 squared and 19 squared. Again, calculator paper. So 441, 361. So we've got our first numbers, 441, 361. Okay, and the next row we're going to do it similarly to how we did the question before. So notice we can actually work out b squared by taking 914 and minusing 289. And on this kind of paper, just use your calculator. So 914 minus 289, that gives us 625. We're going to need to find the square root for the other number. So let's just pop in square root of answer, which is 25. So let's pop in those 2 numbers. So we have 625 and 25. If you start getting decimals, you know you've done something wrong. So do keep that in mind. That's a good way of actually checking what we need to do. Now to go from b squared to b, we need to square root, so that's going to be 7. Again, we do the same subtraction that we did before. So that's going to give us here 121. Again, you could use a calculator for this, and that gives us there 11. And then the bottom one here, well, 1 squared is just 1, 1 squared is 1, 1 plus 1 is 2. Now on to this column, which wasn't very tricky in the previous question, but a little bit trickier now. And let me show you the technique to actually work this out. So I'm going to use the top as an example here. So if you take the 74, the instruction wants us just to divide by 4. So I'm going to do that on the calculator and see what happens. So we do 74 divided by 4. Notice you get 37 over 2, which, if you put as a decimal, is 18.5. So all you need to do is take the number to the left of the decimal point, and the remainder will always be 0.5. And you'll see this for the other parts. So if we do 914 divided by 4, and then give ourselves a decimal, and we get to 228.5. So all we do is put 228, so 228 into here, because the remainder is always going to be the same. If you do 170, so 170 divided by 4, that gives you, well, a nice fraction, but then 42.5, so it's going to be 42 remainder 2. And the bottom one's a bit of a trick question here. So again, we've got 2, so the remainder has always been 2, so we leave that there, and then we just have 0. So I'm assuming that would be the way they want to show the answer. As you can see there, they are happy with that as well. So that last one is just thinking, well, there's nothing there, but you've got the remainder 2 as well. Okay, and on to part B, so a little bit of algebra. So when a is an odd number, a is equal to 2n minus 1. Now the reason that works, by the way, is if you put any number in for n, so say n is 3, as an example, then a would be equal to 2 lots of 3 minus 1. And notice that gives you an odd number. And you can put any number in for n, and you'll always get an odd number. And now we need to use algebra, my favourite topic, to explain why when a is an odd number, a squared divided by 4 has a remainder of 1. So when I see a problem like this, the first thing I want to do is actually work out what a squared is. So a squared is equal to, well, whatever this is, squared. So 2n minus 1 all squared. Now remember, when you're squaring a bracket, it's the same as timesing by itself. So 2n minus 1 times 2n minus 1. And if we use FOIL to expand this, so first, outside, inside, last, let's go through that process. So 2n times 2n is 4n squared. 2n times minus 1 is minus 2n. Minus 1 times 2n is minus 2n. And just be careful on this one. Minus 1 times minus 1 is equal to positive 1, which is really important for this question. Otherwise, bad things will happen. The amount of students I've had, and they say 1 times 1 is just 2, and you go, don't do it. Right, let's cut up the like terms. So notice the middle terms are the same kind of term. So minus 2n minus 2n. So it's minus 2 degrees. It gets 2 degrees colder. It's going to be minus 4 degrees minus 4n plus 1. And what I'm going to do at this point, which is kind of unusual, is I'm going to factorize into a single bracket the start. So I'm going to factorize this part in green into a single bracket. And you'll see why in a moment. So if I do that, what do they have in common? Well, 4. And then let's work out the rest of the bracket. So what do you multiply 4 by to get 4n squared? N squared. What do you multiply 4 by to get minus 4n? Or just minus n. So I've written it in this kind of peculiar form here. And notice, regardless of what this number is, so n is 1, n is 2, n is 5,000, notice it's always going to be a multiple of 4, but then you get a remainder of 1. So all I'm going to do is write down at the end here that this is always a multiple of 4 with remainder 1. So I've used algebra here to show that this, whatever odd number this is, you're always going to get a multiple of 4, but it's going to have a remainder of 1. And now we need to explain why for the values in the table in part A, again, nonlinear paper, let's go back to part A, why n is always 4k plus 2. So always a multiple of 4, and then you have remainder 2. Notice we have remainder 2, remainder 2, remainder 2, remainder 2, remainder 2. So notice every number here in this column and this column is odd. So we have an odd and an odd. So if we go back to what we just did in part I, so an odd number, so you've got A here, for example, that's always going to give you a multiple, a squared, a multiple of 4, remainder 1. Now if we take our next odd number, which is going to be b, so b squared, that's going to be exactly the same. It's going to be a multiple of 4, remainder 1. The same as what we worked out in part A. So if we add them together, so we do the a squared plus b squared, remember that is equal to n here. You can go back to the table and check that here. So if we sum two numbers that are multiples of 4, remainder 1, well, let's just give you some numbers to show here. So 5 would be one of those numbers, for example. And let's say we add that to 17. Now if I add that together, I get 22, which is 4 times 5 plus 2. So notice when I add two numbers that are multiples of 4 remainder 1, what I get is a multiple of 4 still, but notice the remainders get added together. So you get remainder 2. And how do I write that in algebra? Well, I'd write that in algebra as 4 lots of something, so k, and then you have the plus 2, the remainder 2. So that's a kind of strange question, really testing your understanding here of what's going on. But notice in this table specifically, I have two odd numbers for a and b. Notice, go back to question 1, I had two even numbers. We didn't really talk about that. We will do in question 3. And notice you get a different remainder depending on whether you have two odd numbers to start with or two even numbers. And you're probably going to see where the investigation is going here. Now, when a and b are both odd, n is equal to 4k plus 2, so we just established that. Not all multiples of 4 plus 2 can be written as the sum of square numbers. And we want to find all the values of k from 1 to 9, where n is equal to a plus b squared. So this is all about structuring and making sure you're happy with exactly what we're looking for. So let me take 4k plus 2. And let's work out all the different values of k from 1 to 9. So I'm going to do a very nice, neat table here. So let's do that. And what I'll do is we're going to work out what all those numbers are and then see whether any of them work. So we're going to pop in our value k here and then n. Remember, n is equal to 4k plus 2. So we want to go from 1 to 9. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So first of all, we want to work out what numbers we're actually looking at here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we need to work out, when we put k into this, what do we generate out? So, for example, the first one here, so 4k plus 2, so I'm going to do 4 lots of 1 plus 2, that's equal to 6. For this one, I'm going to do 4 lots of 2 plus 2, that's equal to 10. And you can see it goes up in 4s here, so 14, 18, 22, 26, 30, 34, and 38. And what we want to do here is actually just establish with odd numbers only, remember a and b are both odd, which of these can actually be generated. So we're only working with odd numbers here. Notice a and b are both odd. So let's start with just the first two odd numbers. So 1 squared plus 3 squared. Well, that's going to be equal to 10. Okay, that's in my table, so let's give that a tick. The next odd numbers, we could try 1 squared plus 5 squared. That gives us 26. Let's give that a tick. Like so. Oh, I missed out 3 squared and 3 squared, so you can do the same number twice. That's fine. That gives me 18. Okay, tick. And what's the next one? 3 squared plus 5 squared. Just being systematic about it. So 25 plus 9, that's equal to 34. And that's also in my table. Notice if I do the next logical one, which would probably be 5 squared plus 5 squared, or maybe 7 squared plus 1 squared. Actually, they're both the same result here, both 50. Notice 50 is not in my table. So I want to go up from k from 1 to 9, so 38 is my last number I'm going to check. And all we do at this point is just put the values of k that I've put a tick by into the answer. So k is equal to 2, 4, 6, and 8, like so. The key with this kind of question is really be systematic in what you're doing. Read the question carefully. I want you to work with odd square numbers here, and then you can work out all the answers actually quite easily once you've gone through it. Okay, there's a mark scheme for 2A and 2B, and also they've done it in a table format as well, which is certainly the way I would approach it as well. Okay, and on to question 3, so taking our understanding a little bit further here, the values of n that can be written as the sum of two square numbers are of the form 4k plus r, where the remainder r is a constant. And this is the crucial thing about this paper, using questions 1 and 2 to help you with this one. So explain why r can be 0, 1 or 2, it cannot be 3. So if we go back to question 1, we had an even number squared plus an even number squared, and that led, if we go back to question 1 here, to just 4 lots of k. Yeah, so n is equal to 4k. So I'm just going to write that down, use that information. So that gives us 4k, well, just plus 0, okay? So that's that situation. So it can be 0. If we look at question 2, where we investigated two odd numbers, so if we take an odd number squared plus an odd number squared, now that led to, let's remind ourselves, n is equal to 4k plus 2. Okay, so that means 2 is fine. So the only situation we haven't looked at so far is an odd number squared plus an even number squared. And I think the most straightforward way of doing this is let's just take an odd number and even number and see what happens. So say we take 3 squared and we add it to 2 squared. Okay, odd and even. Now if we do that, we get the answer of 30. And notice that's equal to 3 lots of 4 plus 1. Now let's take another example. Yeah, let's just go with 4 and 3. So if we do 3 squared plus 4 squared. Okay, well that's equal to 25. Okay, 9 plus 16. And that would be equal to 6 lots of 4 plus 1. So notice we're always getting this remainder 1 afterwards. Yeah? So it can be written in the form 4k plus 1. So notice we've covered all possibilities. So all possibilities covered. Because you either have even, odd, or odd, even, and it doesn't matter which way round. So all possibilities covered. Therefore, R cannot be 3. Yeah, because it's not a number that's not odd or not even. Yeah, if that makes sense. So cannot be 3. Okay, so that's the way I've gone through it, just going through systematically through the possibilities, using questions 1 and 2. That's really, really important to then make sure that you've got the correct answer there. So question 1, I did this. Question 2, I did this. I've covered the last situation, and therefore I've got to my answer. Okay, and again, n is equal to a squared plus b squared. Find all the values of n where n is between 10 and 30 that are of the form 4k plus 1. So again, we're going to set up a table here in a similar way to what we did before. Now notice our condition is slightly different here to what we did before. Let me get a nice big table ready to go. So we've got k, and then we've got this 4k plus 1. And notice if we put k as 1 in, we get 5, but 5 is not between 10 and 30. 2 likewise, so we're actually going to start with k is 3. And if we do in this one here, 4 lots of 3 plus 1, that gives us 13, which is fine because it's between 10 and 30. And so let's pop in 4, 5, 6. How far do we need to go? Let's go up to 8. And notice this goes up in 4s, but you could check here. It's going to be 4 lots of 4 plus 1, so that's equal to 17. And we just keep adding on 4, so 21, 25, 29. And we stop actually, so we don't actually need this one. So what we need to do is basically do kind of by trial and error here, work out which of these can be formed by a mixture of odd and even square numbers. So 1 odd and 1 even. And generally you can spot this fairly quickly. So let's start with 13 first of all. Well, I think I did that in my example, yeah. So 3 squared plus 2 squared. So notice 3 squared plus 2 squared is equal to 13. So that's fine. So as we go through, just tick this off. So that's fine. 17, yep, that's 1 squared plus 4 squared. 17, so that works. 21. 16 and 5, no, that doesn't work. 9 and 12, that doesn't work. Okay, so I'm going to come back to 21. 25, I did 25 already. That's 3 squared plus 4 squared. 3 plus 4 squared is equal to 25, so that works. 29. 29, yes, 5 squared plus 1 squared, plus 2 squared, that's it. So 5 squared plus 2 squared, that's equal to 29. Notice one has to be odd, one has to be even. So our final answer is going to be 13, 17, 25 and 29. Hopefully 21 doesn't work. I don't think it does. No, it doesn't. Good, perfect. Okay, so you can see the mark scheme there. So exactly, this systematic approach is really, really important, particularly on this paper 6. So that's the investigation paper looked at. So we're going to move on now and look at the modelling.
Okay, so we're going to talk about production boundaries. So this is the second part of this paper, and it's all about the number of computer tablets and mobile phones that this particular company can sell. It has two factories, so we'll talk about factory A here, and then in the part 5 and 6 we're going to talk about the B tablets and B phones and how we produce those. And production boundary is just this curve or line. You'll notice for this question here it will be a curve, and that curve represents the maximum amount of the two items that factory can make when all the resources are used. And this is what we're essentially going to consider mostly through this question. So this is a little bit different to some of the other paper 6s I've gone through already, but I'll try and make as much sense for it as possible. So question 4. Factory A makes T lots of A tablets. So notice this bottom axis, the x-axis as we generally call it, represents the number of A tablets, and then the y-axis, or P in this case, is going to represent the number of A phones that are sold each day. And they use this model here, so 9,000 minus T squared over 1,000, where T is greater than or equal to 0, as that production boundary for the output. And the first thing that we need to do is sketch this model. So this is where the graphical calculator is really, really important. So make sure you've got it for your paper 6, and we're going to go over, plot it in, and see what we get. Okay, so make sure you've got your graph function ready. So if you're not sure where that comes from, then just go to New, and we want to go to Add Graph. So this is the number 2 on the TI Inspire. And before we're going to do anything here, we're going to change the window settings so it looks exactly like the graph that we're going to sketch on. Now, how do you do this? Well, we go to Menu, we go to Window Zoom, and then we go to Window Settings at the top here. And we want to make sure the graph looks like this. So we want the x-axis to go from 0 to 4,000. So I'm going to change this from 0 to 4,000. And the y-axis we want to go from 0 to 10,000. Just so when we actually put the function in, it looks exactly as we need to sketch it. So there we are, popped it in, and now we've got the scale that we want. And now we're going to copy this equation here to the right of the P, and we're going to put that into our calculator. Make sure we change that T to an X, because our calculator only understands X's and Y's. So we're going to pop that in, 9,000 minus, and then we want a fraction, so Control divide. And then we're going to put X squared, not square root, but we want X squared. There we are. And then on the bottom we want 1,000. And notice we're going to get this graph here. Now, generally speaking, this will not be enough to just give you the full 2 marks. What we're going to need to do is find the intersection points with the axes. Now, there's a couple of ways you can do this. I'm going to use this time graph trace. So you can do this on the TI-84 as well. And by using graph trace, I can actually move along the function. And notice when we get to here, it actually tells us it's the y-intercept, so that's very useful. So the y-intercept is going to be 9,000. We'll need to mark that on our diagram. And if we go the other way, so we just drag and go all the way along, you'll see that the 0, so where it crosses the x-axis, is at 3,000. So when we actually draw this, we're going to get a mark for drawing the general shape of the graph and try and make sure it's a smooth curve. But notice we also need to label these, and this will be helpful later in the question anyway, even if it didn't really want us to put it on as well. So we're going to draw the general shape of the graph, but we're also going to label those x-intercepts and y-intercepts. And again, question B actually follows on from that. So when factory A makes 9,000 A phones, it cannot make any A tablets. So this is what the 9,000 means. It means when they produce 9,000 A phones, they produce 0 A tablets. And the question wants us to write down the maximum number of A tablets you can make when it does not make any A phones. So essentially the other way round. So notice this number here, 3,000. So when we make 3,000 tablets, we make 0 A phones. So this question just wants us to interpret the graph and the numbers that we've just generated for part A. So all we need to do is write down 3,000 A tablets, because that's when no A phones are produced. And this question again takes the graph and then uses it in a slightly different way here. So on Monday, factory A makes 1,000 A tablets, and on Tuesday it makes 1,500. And then we want to work out the decrease in the maximum number of A phones it can make from Monday to Tuesday. So if we actually go to our graph and actually look at how this looks, so we've got A tablets. So if I mark this on, and this is not necessary for the question, say this is 1,000 here, and this is 1,500. What we're actually looking for here is, if I use my graph here, and read off, and pop this graph in, and read off, what we need to do is work out these two values here and here, and we want to work out the maximum decrease, so the difference between those numbers. Now we could use our graph, but we could also use the formula here as well. So what we're going to do is we're going to substitute in 1,000 into the formula, and then we're going to substitute 1,500 into the formula to generate P for those specific values. In fact, I'll do it here. So when T is equal to 1,000, then P is equal to 9,000 minus 1,000 squared divided by 1,000. I'm going to use our calculator in a moment to work that out, and we're going to do exactly the same for T equals 1,500, and then we can generate the value of P, so 9,000 minus 1,500 squared over 1,000. So let's go to the calculator, generate those answers, and then you can see how I'm going to use that for the final answer. Let's work this out. So we get 9,000 minus control 1,000 squared divided by 1,000. So that generates 8,000 for me. And let's do the same thing again. So 9,000 minus fraction button 1,500 squared over 1,000. That gives me 6,750. So let's pop those answers in. So 8,000 here, 6,750. Now I'd write this working, of course, under part C, but just so you can see the diagram at the same time, I've written it here. And then they want the maximum decrease. So all we do is take those answers and minus them from each other. Again, you could do this on your calculator as well, but you'll see we get 1,250. So I'm just going to write that in as my answer. So the decrease here is equal to 1,250. On to part D. So factory A makes 5,000 A phones. Use your graph from part A to explain why it's not possible for it to make 2,500 A tablets on the Wednesday. Okay, so if we go to our graphs, go A phones this time. So say we mark in 5,000. What we want to do is kind of work backwards to what we did here. So let me use a different color and go across and then go downwards. So we want to work out this value here such that when we have 5,000 those, the maximum value of tablets that we can produce. Now we can actually use the formula here as well. So we can do a variety of different methods. Actually, we'll use the graph in this case. So let's go over and use my graph from the GDC. So the easiest way of probably doing this is actually, let's just put 5,000 in. So I'm going to actually draw this line in. Now the way we do this is just press tab, and then we just put in 5,000. Notice you get the straight line that goes across, and we want to work out where it intersects. So all we need to do is go to Menu, Analyze Graph and Intersection, and you'll notice that we actually get the value here of 2,000. Okay, so when we produce 5,000 phones, we actually only get 2,000 tablets. So let's go back to the question. So maximum number of tablets produced from graph is 2,000. And 2,000 is, of course, less than 2,500, so not possible. So I'm just making it very, very clear to the examiner that I've used my graph here to actually then establish that 2,000, of course, is not 2,500, so I produce 500 less using the maximum resources. Now on this graph in part A, shade the region that represents the number of A phones and A tablets that the factory can make. So this is using the idea of the boundary here. So if I look at the graph that I've got here, so let's do this in green, I can produce anything below that line. So this entire area under the graph, so I'm just going to shade in that in green. So the entire area represents the amount of phones and tablets I make. Now it will be under capacity, but the red line represents that boundary of the very maximum I can produce of both. So I just want us to shade under the graph here. And now the company sells all the A phones and A tablets that factory makes each day. And the company makes $160 profit for the tablets. So that's the T values here. And $100 profit for each A phone it sells, which is the P value, like so. And the greatest possible daily profit is $964,000. And somehow from that, we need to work out a linear equation. So let me go through the procedure here to make an equation that makes sense. So the letter that represents the amount of tablets we produce is T. And if we multiply that by 160, that will represent, so let me just label this, that represents the total amount of profit from the tablets, T for tablets. And if we write down then 100p, this expression, so 100 times the amount of phones I sell, that's going to represent, and let's put this in green, the profit from the phones. And in order to work out the maximum profit, I need to add the two profits from both the tablets and the phones together. And so if I add those together, that will give me my maximum profit, or the greatest possible. And we're told in the question that's equal to $964,000. So I've generated this equation from the information in the question. So $160 profit for each A tablet and $100 profit for each A phone it sells. Now at the moment, this doesn't look like the equation that we want. We want to get P on its own. Notice that. So we need to go through our normal equation solving to do that. So if I write this over here, just in a more condensed format, so 100p is equal to $964,000. So we want to get the 100p on its own. So what's the opposite of adding 160t? Well, we're going to minus 160t from both sides. And this is where the skills from papers 2 and 4 come into play here. Now this cancels, so we're left with 100p, which is what we wanted, equals minus 160t plus 964,000. And now we want P on its own. So what's the opposite of timesing by 100? Well, we want to divide by 100 on both sides. If we do that, that cancels, which is very helpful. So we get P on its own, which is exactly what we wanted. And at this point, we divide it by 100. It makes it kind of easy. So that gives us minus 1.6. And if I divide that by 100, well, those disappear. The two zeros disappear. And we get left with 9,640. So we now get it in the form that they do actually want us for in the question. And the reason they do this will come clear in the next question, because we're actually going to plot this in a moment. So this is the final answer here in the form that they want. So P is minus 1.6t plus 9,640. So M represents minus 1.6 and C represents 9,640. Okay, so now we're going to use this. So find the number of A tablets. So that represents the P here. Sorry, the T here, sorry. And this represents the P. That factory A should sell in order to make a profit of $964,000. Now remember, that's the greatest possible profit that we want to work out. So what we have here is two equations. So we're going to put down what we had before. So P equals minus 1.6t plus 9,640. So that here represents the greatest profit we can make. And if we take the equation from right at the start, so this one here, so P equals 9,000 minus t squared over 1,000. So P equals 9,000 minus t squared over 1,000. That's the maximum production, yeah? That's the maximum we can produce. And we want to find when they intersect. So when we have the maximum profit and the maximum production and when they actually meet each other. So what we're going to do is use our GDC to work this out so we can work out the value of T and P, so the number of tablets we produce, to get the maximum amount of profit with the maximum amount of production that we can do. So let's go to the GDC and work that out. Okay, so we have our graph from before here, and all we're going to do is add in that second function we worked out in part E. So we press on the tab button, and we're going to type that in, so minus 1.6t plus 9,640, and notice that we are going to get a straight line. Notice we don't want to put t in because the calculator doesn't know what t represents, so we need to put x in so it knows what we're working with. Once we pop that in, as you can see, we get a straight line, which we expect because we only have x, not x squared, and we want to find the intersection point. So we just go to Menu, Analyze Graph, Intersection. We click before, click after, and then we get the two answers that we're looking for. So 800 and 8,360. So remember, the first number represents the t value, and then the P is 8,360. So that gives us the amount of tablets and phones in order to get the maximum profit for the maximum production. So T is equal to 800 and P is equal to 8,360, like so. Right, so you can have a look through the mark scheme. So this is question 4, and where I'm picking up those communication marks, which are really, really important. So showing you're working in 4C, for example, here, gives you that C1 mark. Showing those intercepts that I mentioned right at the start, give you that method mark as well. So really do be thorough in exactly how you're actually getting those marks. That's going to be really, really important to achieving that full marks on this paper. Right, on to question 5. So we're going to work with a linear model now, and we actually got a table to work with instead. And notice it works inversely proportional, so as one increases, the other decreases, and we need to draw the production boundary for factory B on the axis below. Now notice we're not actually given from the table the x and y intercepts, but we can work this out. So notice this is going down in 2000. So it's 2000, 2000, 2000, okay, at a linear rate. So that means that when we go down by 2000 again, we get 0, and notice this is going upwards by 1000 when this goes down by 2000. So we can actually add a couple of extra values to our table. This is going to be 5000, 0, and if we work the other direction, so if we get to this one here, we're going to have 10,000, and this will be 0. So notice I'm just using the table to actually work out the values I'm looking for my graph. Now once I've done that, I can actually just draw this very directly onto here. So notice the y-intercept, remember P is on the y-axis here, it's going to be 10,000, so I can just pop in 10,000. And on the t-axis I can pop in 5,000, because I know when the other value is 0. And once I draw that in, then I can just connect this up with a straight line. Now I'll do my best to do a straight line at home. Okay, so do bear with me. Okay, how are we looking? A little bit wobbly, but I think that's not too bad. So for this question, you need to work out, again, just like before, the x and y intercepts, and then draw that in this case with a straight line. So we have our graph there. And now we need to find the equation which models this production boundary, giving P as a function of T. So essentially we want to find the equation of this straight line. So to find the equation of a straight line, we need the gradient, which we'll work out in a moment, and the y-intercept. Now we already know the y-intercept from what we did in the first part of the question. Where does it cross the y-axis, or p-axis in this case? Well, that's going to be 10,000. And remember, to work out the gradient, we need to do rise over run. Now you probably think we don't have enough information to do this. Well, we actually do. We can actually use the intercepts we worked out before. So I'm going to use this really, really big triangle to actually work out the gradient. The height of this triangle is equal to 10,000 because it starts at 0 at the bottom. This is going to be 5,000. If I use my formula of rise over run, well, the rise is 10,000, or negative 10,000 because we're going downwards. Remember, the line is sloping downwards. And the run is equal to 5,000. And that's just going to generate our answer here. Now you can do this on the calculator, of course, but that will give us -2. So actually we have all the information we need here to actually put in our line. Now, normally we talk about y equals mx plus c. So if we're using that and we put in the gradient and y-intercept, so m and c, we would then get y is equal to, well, the gradient is minus 2, the minus 2x plus 10,000. However, read the question carefully, giving p as a function of t. So the t value is essentially our x-axis, and the p-value is actually our y-axis. Very weird me saying p-value because that comes into stats quite a bit. So all we need to do here is swap over the y's and x's with the letters that we have. So we just put in p is equal to minus 2t plus 10,000. And that's going to be our answer. So actually, this is just a using equation of straight line technique, essentially, but just applying it to a slightly different situation. Now, part 3, factory B makes at least, very important, at least, so it includes 1,000 B tablets, but no more than 4,000 B tablets each day. And write down the domain, it's an important word to know, of the model that we just generated. So remember, the tablets is referring to the T here, of course, T for tablets, and the limits here are 1,000 and 4,000, and this is what determines what T can be. Now, the careful thing we have to be here is with the inequality symbols. So T is greater than or less than 1,000, and T is less than or equal to 4,000. Notice we put the lines under our inequality because they can produce exactly 1,000 and they can produce exactly 4,000 as well. So just be very careful when you're actually writing the domain, so what the t values can be here when you're putting this down onto paper. Okay, and now we're moving on to a little bit more tricky question here. So the company sells all the tablets and phones that are produced. The company makes $200 profit for each B tablet and $190 for each B phone it sells. And each day, the manager of Factory B expects to make the greatest possible profit. So very similar to the previous question. And then find that greatest possible profit each day. So this is a bit trickier because we're not told, okay, how much that is going to be. So let's go back to our table. If we actually look at our table here, when do we produce the most stuff? So think of it this way. Well, on this row, we produce 9,000. The top row, we produce 10,000. This next row here, we produce 8,000. And then we produce 7,000. So on the surface, it looks like we should just be producing lots and lots of phones and no tablets. However, we have to be a little bit careful and use the condition from before. So notice the factory has to create at least 1,000 B tablets. So that means the minimum number has to be 1,000, and therefore we have to produce then 8,000 for the maximum of B phones. So the biggest number actually from this table and from this graph is actually the 9,000, because we have this condition now, we have to produce 1,000 B tablets. And 9,000 is more than 8,000 or 7,000. So that's the first thing we have to conclude here, that in order to create the greatest amount of profit, put a pen in, we need to produce 1,000 B tablets and 8,000 B phones. That's the most important thing. Right, so once we've established that, actually this is quite easy to calculate. We do it in a similar way to what we did before. So you make $200 profit for each B tablet, so that's going to be 1,000 times 200. That's the total profit for the tablets. And then $190 profit for each phone. So we do 190 times 8,000. Again, there's no need to do this in the calculator in any shape or form. Mentally in any shape or form, so let's use the calculator. Okay, so we just type it in. So let's get the brackets ready. So 1,000 times 200, close brackets, plus, open bracket, 190 times 8,000, close bracket. And then we get 172 and then 4 zeros. So 172 and then 1, 2, 3, 4. And now let's actually convert this into money. So we're talking about dollars here, so make sure you've got the dollar sign. You don't want to lose a communication mark. And if we look at this, it's going to be $1,720,000. Notice technique I did here, I just put the number down and then I broke it down into, is it 1 million, is it 10 million, and then put the number in very, very carefully. So we get $1,720,000. One day, factory B has to make 2,500 B tablets. On this day, the profit is 73.3% of the greatest possible profit, which we've just worked out. So that's work out the number of B phones factory B makes on this day. Right, so the first thing I want to do is work out the profit that is made, the total profit. So total profit is equal to 73.3% of what I just worked out. So $1,720,000. So let's just get the calculator to do that quickly. So what we need to do here, remember we can use multipliers here, so we can do 0.733 times 1,720,000, 4 zeros, just double checking everything, and we get 1260760. Let me just write that down. So 126. Okay. Memory's not good today. 1260760. Perfect. 760. Okay, so that's the total profit. So let's now set this up so we can actually work out what's going on. So we've got one day, factory B is producing 2,500 tablets. So the profit from that is going to be 2,500 multiplied by the profit made on tablets, which is 200. Put that in brackets. Plus 190, which is the profit per phone. We don't know how many phones, so I'm just going to put a P for phones. And that needs to be equal to this big number that just produced here, so 1,260,760. So essentially at this point, this is just an equation to solve. So let's simplify this down slightly. So let's pop this in. So we've got 2,500 times 200. So let's just get the calculator to do parts of this. So, doesn't like me. There we are. 2,500 times 200. Give me 500,000. Just being very careful when I'm working these things out. Got the calculator for the exam, so there's no reason why I can't use it. And now this is just an equation to solve at this point. So the first thing that we do is remove that 500,000. What's the opposite? Well, minus it. Notice I'm not going to rush to my calculator until the very end here. So 500,000. So we get 190p equals 1,267.60 minus 500,000. And then to get the p on its own here, so let me just write this up here nice and clearly, is going to be divided by 190 on both sides, so we need to do 1,260,760 minus 500,000, and then we need to divide all of that by 190. So now I've got that calculation ready, let's go to the calculator and do it. So we want a fraction, we want 1,260,760 minus 500,000. That's it, divide by 190. Boom, and we get an exact answer here. That's nice. Good sign, and 4,004. So 4,004. So P is going to equal 4,004. Perfect. And you can have a look through the mark scheme, so where I'm putting these things up. Again, just be careful with your inequality symbols here. Again, you could write this slightly differently. So say 10,000 minus 2t would probably be fine as well. And 4,004 for that bit tricky question at the end. This is why I do these walkthroughs, because you look at the mark scheme here, it's like, where does this come from? And hopefully this explanation just makes it a little clearer. Okay, and on to the last part, question 6, which actually isn't as hard as it looks on the surface. So the company puts new machinery in to make phones in factories A and B. Factory A can now make double, that's important, so times 2, the number of A phones, and factory B can now make 10% more B phones. Okay, that's important to know. All other conditions remain the same. Complete the following models for the production boundaries after the changes. Use the models in question 4 and 5a. So question 4, just go right back. Let's go right back. The very first thing that we did. This is the model to represent the number of phones. And they've said that the number of phones doubles. So all we need to do is take this function and then just multiply it by 2. Because remember, it's equal to the number of phones. So the first part is actually reasonably straightforward. So for this one, we take 2 lots of the previous model, which is 9,000 minus t squared over 1,000. Okay, so that's all they're asking us to do. How do we put that in terms of functions? Now for the next question, they produce 10% more B phones. So we've got our model here, and they want to give us the condition for t. So if I go back, remember what we wrote last time. So we have to produce at least 1,000 B tablets, but between 1,000 and 4,000. That hasn't changed. That hasn't changed here. 10% more B phones, that's changed, but the condition still remains the same. So this is still going to stay between 1,000 and 4,000. Just because we're producing more B phones, or 10% more, doesn't mean that condition for the tablets has changed in the slightest. Now after the changes, the greatest possible profit made each day by factory A is this figure here, and we want the total greatest profit each day by the company. So what we need to do is work out the greatest profit for factory B, and then just add that to that number I underlined. So greatest profit for factory B. Okay, so if we think about what happened before in question 5, notice that we had 1,000 B tablets and 8,000 B phones. Now we produce 10% more B phones. So the first thing we need to do is increase by 10% 8,000, because that was the maximum. So if we increase that by 10,000, increase by 10% 8,000, that's equal to 1.1 times 8,000, which you can put into your calculator, of course, but this will give you the answer of 8,800, like so. And now essentially we use the formula from before. So remember what I did before here. I did 1,000 times 200 plus 190 times 8,000 to work out the greatest possible profit. I'm going to use exactly the same formula here, but instead of 8,000, I'm going to use 8,800. So all we need to do is just do 1,000 times 200 plus 190 was the profit times 8,800. This will then give us the total profit for factory B, and then to work out the total, we're going to add in the 1,830. So if we add in this as well, 1,830,000. So this here is going to give me the total profit from both factories. So all I need to do is now put this into my calculator. We're not going to put a 4 there, that's not a good idea. So let's just put this in really, really carefully. So 1,000 times 200, because that hasn't changed, the tablets hasn't changed, but the phones have, B phones have. And just making sure everything, don't put too many 8s, for example. This is where you just need concentration. Make sure everything is where it should be. So 8, 0, 0, 0, 0. Double check. Yep, I'm happy with that. And we get our final answer for 3702 and 3 zeros. And let's just put this in money. Again, communication is critical here. So we get $3,702,000 as our final answer. And you can have a look at the mark scheme and see how they've broken it down as well. Interestingly, you could have done it by doing a sketch. That's an interesting approach, actually. But I think once we just realise the tablets has to stay the same here, and then all we need to do is change the phones just marginally, then I think that's the more straightforward way to go about the question. So if you like this video, again, please do give it a like. It does help spread this video, particularly before the exam coming up very, very shortly, to as many people as possible. And if you want to practice your Paper 6 skills before that exam coming up, then check out the playlist right in front of you, because I've done a ton of Paper 6 walkthroughs that can be really, really helpful for you when the exam comes.